Welcome to lesson 4.3, solving quadratics by completing the square. Completing the square, it's a process by which you add a constant c to an expression in the form ax squared plus bx so that ax squared plus bx plus c becomes a perfect square. Completing the square changes the standard form of a quadratic to the vertex form of a quadratic. So we have to find 1/2 of b, which is the coefficient of the x term, and divide it by 2. We square that result, and then we add and subtract the result from step 2 to x squared plus bx. Then we factor the perfect square trinomial, and then we get the resulting expression. So let's take a look at an example. If we take something like y equals x squared plus 6x minus 7, we have a quadratic function in standard form. When we complete the square, the first thing we do is we group the first terms. So x squared plus 6x, we group that. Then we take a look at what is b being the coefficient of the x term. And in this case, it's 6. So we take that coefficient 6, we divide it by 2, and then we square it. And in this case, we get 9. So we go back to our quadratic and we write y equals bracket x squared plus 6x, and then we add 9 and we subtract 9. This is the process of completing the square. Now, what we want to do is move this -9 out of the brackets and combine it with the -7 that's out there. So y equals x squared plus 6x plus 9 minus 9 minus 7. What we've done here is we've created a perfect square trinomial. And when we factor a perfect square trinomial, we will get x plus 3 squared minus 16. So we've taken our standard form of the equation and put it into vertex form of a quadratic. And here, my vertex is made up of the h and the k. And in this case, it's -3. H is always negative or opposite. And then the k is -16. So that's where my vertex is for this particular example. Let's take a look at b. We start the same way and we group the first two terms. We take a look at the coefficient in front of the x term. In this case, it's -8. So we have -8. We divide it by 2, and then we square it. So in this case, I have 16. If I go back to my quadratic equation, y equals bracket x squared minus 8x. And in the bracket, I'm going to add 16 and minus 16. And then I still have -4 to the right of the brackets. Then we want to move the -16 out of the brackets. So we'll have y equals x squared minus 8x plus 16. We'll close our brackets and we move that -16 out, and now we'll have to combine it with -4. So again, we've created a perfect square trinomial. And so when I rewrite it, I put it in brackets x minus 4 squared and then minus 20. So my vertex here, h and k, in this case, h is 4 and the k is -20. All right, so those are two examples where our coefficient on the x squared term is 1, but let's take a look at some examples where that is not 1. So again, let's start by grouping the first two terms. we take a look at the coefficient of x, and in this case, it's 20, but we also have a coefficient in front of the x squared term, that's 2. And if I consider both of them, we see that we can factor out a 2. Now, we don't want to touch the x's. We're only talking about factoring out the coefficient. So if I factor out 2, I'll have x squared plus 10x. And we didn't factor anything from the -1 outside the bracket. What that does now is I have a smaller b. Now I have 10. So I'll take that coefficient 10, divide it by 2, and square it, and I'll get 25. I go back to my function, y equals 2, bracket x squared plus 10x. Here we're going to add 25 and subtract 25, close our brackets, and we still have -1 out on the side. Now again, I want to take this -25 out of the bracket, but we have a coefficient in front of the bracket. So what you have to remember to do here is multiply it by that coefficient before you actually move it out. So we'll have 2 times bracket x squared plus 10x plus 25. We close our brackets, but now we have to take our -25, multiply it by the coefficient of 2 before we move it out of the bracket. So we end up with -50 minus 1. Simplifying our trinomial, y equals 2 times bracket x plus 5 squared minus 51. So the vertex that I find here is -5, -51. So we will do another example like that, again, where the coefficient in front of the x term is not 1. So let's go ahead and group our first 2 terms. We notice that we have a coefficient in front of x squared that is not 1, it's 4. So we are going to factor out and only the coefficient, not an x. So y equals 4x squared plus 6x. And then we have -15 on the outside of the bracket. That then gives us 6, a smaller value for the coefficient of the x term. It's helpful. So 6 divided by 2 squared, and that equals 9. So we go back and we will add 9 and subtract 9. So 4 bracket times x squared plus 6x plus 9 minus 9 in brackets. And we still haven't done anything with this -15 on the outside of the bracket. Now again, we want to go and move this -9 outside the bracket, but we have a coefficient here of 4. So before we move it out, we have to multiply by that coefficient. So let's go ahead and do that. Y then equals 4 times bracket x squared plus 6x plus 9, and we're multiplying -9 times 4. I'll get -36 minus 15. So I have to multiply that -9 by the coefficient before I move it out. We have our perfect square trinomial here. So we'll simplify with y equals 4 times bracket x plus 3 squared, and -36 minus 15 is -51. So my vertex here is -3, -51. All right, let's move on. We're going to take a look at solving quadratic equations that are in this form, x squared plus bx equals c. And remember, to solve something, we have to make sure one side is equal to 0. So if I take a look at my first example, I have x squared minus 16 equals -15. Well, one side is not equal 0. So what I'm going to do is I'm going to bring this negative 15 over to the left side, and that way my right side will equal 0. But when I simplify, x squared minus 16 plus 15 as you bring it over is negative 1, and that equals 0. Now what we are left with right here on the left side is a special factoring pattern. And maybe you recognize it, but it's two terms, and it's separated by a subtraction sign. And so we call this, or we know this, as a difference of squares. And when we factor something like that, we will have one term that's positive, or one factor that's positive, and one that's negative. So we fill that in x minus 1 and x plus 1. Zero product property allows us to take each factor, x minus 1, and set it equal to 0. In this case, x equals 1. And then we take the second factor, x plus 1 equals 0, and x in this case equals negative 1. So my solutions for this quadratic is negative 1 and positive 1. And so that is where the parabola will cross the x-axis at 1 and negative 1. If we take a look at B, we have x squared minus 4x on the left, and we have 2x minus 8 on the right. And I want to go ahead and make one side equal 0. So I'm going to move the 2x to the left side as well as the negative 8. So watch your signs, they switch. So I'm going to write them out so we see them. X squared minus 4x, 2x becomes negative 2x, and negative 8 becomes positive 8. That leaves me with the right side that is equal to 0. And then let's combine or collect our like terms in the middle here. So we have x squared minus 6x plus 8 equals 0. And when we want to solve this, sometimes you think, okay, well, the quickest way to do this is maybe factoring it. But if you take a look at these numbers, it's not going to easily be factored. So what we'll do here then is we'll complete the square and then go from there. So remember how we complete the square is we are going to group the first two terms. We're going to take a look at the coefficient of the x term, in which case it's negative 6. I'm going to take that negative 6, divide it by 2, and I'm going to square it. And that's going to give me 9. I go back and I'm going to add 9 and subtract 9. So x squared minus 6x plus 9 minus 9 plus 8 on the outside of the bracket is equal to 0. We have to move one of those terms outside the bracket. We don't have a coefficient to multiply by, so we just can move it. So x squared minus 6x plus 9, and we move out negative 9 plus 8, and that equals 0. We simplify our perfect square trinomial that's right here, and we will have x minus 3 squared minus 1 equals 0. So we have this vertex form of our quadratic, and we're going to solve this. We're going to start working with this vertex form. So I'm going to move this negative 1 over, and I will have x minus 3 squared equals positive 1. Now to undo this, we have to take the square root. So we take the square root of each side, and on the left I'll have x minus 3. And on the right, remember, we have to have a plus and a minus 1, because negative 1 squared would equal 1, and positive 1 squared is also going to equal 1. So we have two situations here. Then we're going to split this, or actually we're going to move the 3 over first. A negative 3 is going to become a positive 3. So here, x is equal to 3 plus or minus 1. So to find our actual solutions, one of them is going to be x equals 3 plus 1. In this case, x equals 4. And the other one will be x equals 3 minus 1. In this case, x equals 2. Great. We'll take a look at a couple more examples. X squared minus 2x equals 3. Let's go ahead and move that 3 over to the other side. So we have created the right side equal to 0. So we have x squared minus 2x plus 3. Oh, sorry, negative 3. We have to switch the sign. Minus 3 equals 0. Now we take a look at our c value and our b value. First, can we factor it? If you think of the factors of negative 3, and then two numbers that multiply give you negative 3, but add to give you negative 1. One thing I can think of here would be negative 3 and positive 1. And negative 3 plus 1 will give me negative 2. That's the coefficient of the middle term. So this one was easily factored. Let's go ahead and just write it in factored form. X minus 3 in bracket times x plus 1 in brackets, and that equals 0. Now we split them using the zero product property. So x minus 3 is equal to 0. So x is equal to 3 here. And we can also take the other factor, x plus 1 is equal to 0. And simplifying here, x equals negative 1. So there are two solutions for this quadratic. So again, with this one, we have a negative 8 on the right side. Let's move that over. Set the right side equal to 0. So I will have x squared plus 12x plus 8 equals 0. Can we think of some numbers that are multiplied together to give us 8, but then add together to give us 12? Those are some difficult numbers to deal with. I can't think of any factors that would do that. So I'm going to complete the square. So we're going to start by grouping the first two terms. And we're going to take a look at the middle term's coefficient, which is 12. So I'll take 12, I'll divide it by 2, and then I square it. So I get 36 here. I'm going back to my function, x squared plus 12x. Now I add 36 and I subtract the 36. I still have a positive 8 on the outside of the bracket, and the whole equation is equal to 0. I want to move the negative 36 out of the bracket. I don't have an alternate coefficient to worry about, so x squared plus 12x plus 36. And I move the minus 36 out, and we'll have to add 8 to it. So let's simplify our perfect square trinomial now here. So that will give us x plus 6 squared minus, this is going to be 28 equals 0. Now that we have it in vertex form, we can start to manipulate it and solve for x. So let's move negative 28 over, back over to the other side. I'll have x plus 6 squared equals positive 28. And then to undo squared, I have to take the square root of both sides. So I have x plus 6 equals plus or minus. We can actually split 28 into 4 times 7, right? And that's a radical property, square root property. And then I'll simplify again, x plus 6 equals square root of 4 is 2, so that'll be plus or minus 2 times the square root of 7. Not quite done yet. Let's solve for x by moving the positive 6 over to the other side. So I will have x equals negative 6 plus or minus 2 times the square root of 7. So my two factors here, if I go ahead and I split them, one of them is going to be equal to x. Negative 6 plus 2 times the square root of 7. And then the other one is going to be x is equal to negative 6 minus 2 times the square root of 7. And you can see with these results why we could not factor this quadratic. Let's move now to talk about finding and using the maximum and minimum values. So another reason why this completing the square is helpful is if we can change standard form to vertex form, we're able to find the maximum and minimum values for the quadratic function. So let's say we're looking for the maximum value, example 3. It's just going to be a little bit of a repeat. We don't know what the minimum value is. The only thing we do know for sure here, just by inspection, is that the y-intercept is always the constant when you're in standard form. But that doesn't really help me with trying to find the maximum or minimum value. So in order to do that, we complete the square and we we group the first two terms. We take the coefficient of the x squared term, in this case 4. 4, divide that by 2, we square it, and that equals 4. So I will have y equals bracket x squared plus 4x. I'm going to add 4, subtract 4, close my brackets, and I have negative 1 outside. Y equals, let's move this negative 4 out. So we have x squared plus 4x plus 4, and we've moved negative 4 out to combine that with negative 1. Let's simplify the trinomial. So y equals bracket x plus 2 squared minus 5. So now we have vertex form. And in vertex form, my vertex is negative 2, negative 5. And we know that because the a is positive in this situation, we do have a parabola that opens up. So something that looks like this. And so the vertex would be at the bottom, which means we have a minimum value. Similarly, let's take a look at this one. I really can't tell what the maximum value would be. I do know that it's a parabola that opens down because that is negative in front of the x squared. And I do know the y-intercept is positive 7. And again, doesn't really help me determine what the maximum and minimum is. So I'm going to go ahead and complete the square. I'm going to group the first two terms. Y is equal to, I'm going to take out this negative sign. So minus x squared minus 2x plus 7. Take a look at the coefficient in front of my x term, and it's negative 2. So negative 2 divided by 2, square it, and that's going to equal 1. So y is going to equal to negative times x squared minus 2x plus 1 minus 1, and then I have positive 7 outside the bracket. Now be careful here. We do have a coefficient, and actually a coefficient of negative 1. So when we go to move our negative 1 outside, we have to remember to multiply it. So we have y is equal to negative x squared minus 2x plus 1. And because I have to multiply that negative 1 by negative 1, I'm going to have a positive 1 plus 7. Simplify my perfect square trinomial, and that'll be x minus 1 squared plus 8. So now what does this tell me? Yes, I know that it's a parabola that opens down. My vertex is is 1, 8. So something like that. And we know we're talking about a maximum value. So let's take a look at an application of completing the square and finding the vertex. So for this example, the function y equals negative 16x squared plus 96x represents the height y in feet of a model rocket x seconds after it's launched. Find the maximum height of the rocket and find and interpret the axis of symmetry. So let's take a look at the function y equals negative 16x squared plus 96. And there is no constant at the end here. But in order for us to find a maximum height, we need to know the vertex. So we have to change this form into vertex form. So let's go ahead and group the first two terms, and we're going to factor out that negative 16. So we're dealing with some smaller numbers. So negative 16 times what's left is x squared minus 6x. So now that I have negative 6 as the b, or the coefficient of the x term, I'll take negative 6, I'll divide it by 2, I'll square it, and that'll be 9. So I'm going to come back to my function, and I have negative 16 times bracket x squared minus 6x plus 9 minus 9. So we want to move the minus 9 out of the bracket, but we do also have a coefficient of negative 16 out there. So when we pull it out, we have to remember to multiply that by negative 16. So when we do that, y equals negative 16 x squared minus 6x plus 9. And when we move that over outside of the bracket, it is plus 144. And you can check my calculation there. Then let's go ahead and simplify the perfect square trinomial that's in the middle. So y is equal to negative 16 x minus 3 squared plus 144. So my vertex is 3, 144. So y of 144 means that the height, or the maximum height, of the rocket is 144 feet. The axis of symmetry x equals 3 is the time it takes the rocket to reach that height. Good. All right, so that's it for this lesson. So I'll see you in the next one. Bye-bye.